fun. All right, in 7.3, we are branching off. It's okay, I knew that was there. We're branching off of 1 and 2 where we were learning about ratios and proportions, and now we're going to be applying it to similar polygons, okay? The first thing you need to know about similar polygons is what they are, and what's the symbol for similar polygons. Now, when we say polygons, we mean any number of sides. 6 sides, 5 sides, 4, 3, 10, 12, whatever. Okay, not one-sided though, because then it's not a polygon. Neither is a two-sided. All right, so in similar polygons, they are just like congruent shapes in the fact that they have all of their corresponding angles are congruent to each other. So in this case, you see here 2 hexagons. Why do I say hexagons? Please don't count the lines. Tell me how many sides there are. 6. They each have 6 sides. And the smaller one is labeled A, B, C, D, E, F. And the larger one is labeled A prime, B prime, and so on and so forth. Now, when you see 2 shapes that are labeled in this way, they are identifying for you what the corresponding parts are. Angle A on the small polygon corresponds to angle A prime on the larger one. B and B prime are corresponding together. Now, since similar polygons, their corresponding angles are congruent to each other, that means that angle A here has the same measure as angle A prime. Angle C, I'm skipping around, but just to get you to, wait, yeah, I did that wrong, huh? Would be congruent to angle C prime. And we could go on and we could label it, but I think you kind of get the gist of it, all right? So the first thing is that corresponding angles are congruent to each other. The next thing is this: corresponding sides are not congruent, because it's obvious here that they're not the same, but they are proportional to each other. Okay, now what do I mean by they are proportional? They all have the same ratio when you compare one to the other. Now the way we find that ratio, we look for something called the scale factor. When we're dealing with similar polygons, the first thing that you need to identify is the scale factor. And that basically tells you the relationship from one to the other. It may be 1 to 2, which means that the smaller one is half the size of the larger one, or that the larger one is twice as big as the smaller one. You could have a ratio of 2 to 3, okay? But whatever it is, your very first thing that you need to find is the scale factor. All right, so what do similar polygons have?
Corresponding angles are congruent.
Angles are congruent, corresponding sides are proportional, and that proportion or that ratio is called the scale factor, okay? Also, the symbol to show that 2 polygons are similar, you know the squiggly on top of the congruent sign is only the squiggly, okay? Mm-hmm. So the symbol for similar is this. So if I were to say that 2 triangles were similar, I would say triangle ABC. I would put this symbol to triangle, let's say DEF or whatever. All right? Okay. Both conditions must be met for them to be similar. Not just one or the other. What did I do? Wow. Okay.
I think we hit next. Maybe. I don't know.
It's going to do it again. Oh, well. Let's just go. All right. In these 2 polygons that are drawn, these are quadrilaterals. They look like trapezoids, but do I have enough information to say that they are indeed trapezoids? What do trapezoids have to have?
Two parallel sides.
They have to have a set of parallel sides. And even though they look parallel, are we given the markings? No. Are we given, let's say, same side interior angles and we know that they're supplementary? No. So, yeah, they look like trapezoids, but we don't know for sure that they are. But we do know from the labeling here, because one is labeled A, B, C, D, and the other one is A prime, B prime, C prime, D prime, that these are most likely similar to each other. The little symbol after it means prime. Okay?
Wait, what is the whole prime thing have to do with it?
It's just to indicate that there's another, it's to show that this angle C corresponds to this angle C, but it's not the same point. It's a different point. Okay? All right. Now, if we are told that these two things are similar to each other, then we know this. We know that the corresponding angles are congruent to each other. There is one other angle measure that we absolutely positively know because of that on these figures. Which angle measure do we absolutely positively know since they're similar?
D is 70.
Angle D is equal to 70. We know that because the shapes are similar. Angle D corresponds to D prime, so they are equal to each other. Now, if we knew that this was a trapezoid, we could go ahead and figure out angle A, because we would know that these two things are parallel, but we don't know that. Therefore, we can't figure any of the other angles out. Okay?
We can't do same side and two.
We don't know that the lines are parallel.
What's that only can happen if they're parallel?
Only if they're parallel. All right? Okay, now, what we're going to do first is find a scale factor, because you see on A prime, B prime, the length of that line segment, it's labeled X. And if I wanted to find out how long that segment is, I need to first know, well, what's the relationship between these two things? If they're similar, what's the scale factor? And this is how I do it. I identify a set of corresponding sides where you know both measures. So a side on the small figure and its corresponding side on the large figure where I know both of the measures. So let's start looking. AB, do we know the other AB? So we can't use those two numbers for our scale factor. AD, do we know the other AD?
Yeah.
Yes. Okay, so this is where I get my scale factor from. If you always put the smaller number on top, it just eliminates all confusion, because you got to make sure that you're setting things up the same. AD of the smaller shape has a measure of 3. A prime, D prime has a measure of 5. So the scale factor is 3/5. This scale factor will be used to set up the proportions to find any other missing pieces. If we are looking for X, the measure of AB prime, we're going to set it up in a ratio in this proportion. Is X from the large or the small shape? It's part of the larger shape, okay? So the larger measurement goes on the bottom. Now what goes on the top?
2.
The side from the smaller shape that corresponds to it. Well, X is the distance from A prime to B prime, so its corresponding side is the distance from A to B, which would be 2. Okay? Now how do we solve a proportion? You cross multiply and divide. So 3x is equal to 10, or x is equal to 3 1/3.
So that's the scale factor?
The scale factor is simply this.
Oh, the one thing that you know for sure.
The one thing we know for sure, that is your scale factor. That tells you the size relationship between the two shapes. Now we use that scale factor to find any missing pieces. All right? Okay, let's move on. We already have this. In these two triangles, you've got triangle ABC and you've got triangle A prime, B prime, C prime. Notice the angles that are measured congruent to each other. Now, if you remember when we were doing congruent triangles, we did not have an angle postulate.